We are Team Roboquarium. We are a team of engineers at Heriot-Watt University working on subsea robotics. So today we'll be showcasing our telepresence system. So the idea of a telepresence system is to basically allow operators of ROVs, which are remotely operated vehicles, to carry out inspection work on offshore structures such as wind turbines or oil rigs, and to do all this remotely. So currently what they have is they either have people on the wind farm or in a boat nearby, which can be quite hard on the personal life, as well as high pressure for the single operator. With remote telepresence, the idea is that we can still provide the information necessary to make informed decisions during the mission, as well as having a better understanding of the environment the ROV is in currently. The operator could be safe at home, just operating it as they wish.
And in the water here, we have our BlueRov underwater ROV. So that's a remote operated vehicle. So here inside the tank, you can see our test structure that we use for testing our inspection and the robot sitting in the water. So here we have our operator page. You too can access this page to control the robot. We can see the camera and we can control the robot as it flies around. I can give it a waypoint and it will go to here. Through this interface, we also have control of the arm. We can move it forwards. And while it's forwards, we can close and we can open the gripper. And we can stow the arm sideways, or we can stow it upright. So now we'd like to invite you to access the 360-degree view of the robot.
So this is what you would see as an observer from the website.
So you can scroll around the image to see in each direction, and everybody can pick a different direction.
So if you go to the link that's been provided, you'll be taken to a welcome page where you can either sign up for the operator experience, and then in a bit we'll basically choose a name out of the hat, and you'll get to experience what Josh just demonstrated on your own device at home. Mr. Username Santi, I am going to give you the ability to become the operator. Santi joining. There we are. So that is Santi joining in as the operator just now. So if you want to try pressing any of the buttons for the arms or the grippers, there we go. So that arm, having moved just then, is controlled by Santi. Where are you joining us from, Santi, today? Just to kind of give an idea of where. From London, I see. So within the same country, but still very far. Perfect. I see that you're controlling the arm, but would you like to try? So in the top right virtual image, if you click on the location, then it'll basically send the robot to that location. Is that something happening there? Yes. Okay. Yeah. So it might take a bit of time. So just click once and then give it a moment. And then it will.
Off it goes.
Yeah, so that's it, having started it now. There we are.
So one of the large advantages of having this click-to-go waypoint interface is that while the system, since there's a high latency, since you're controlling it over the internet, being able to click and then the robot to make its own way there is much more preferable over driving the robot forwards, because then you know that the robot's going to stop when it reaches its goal, rather than trying to stop when you see the object in front of you, but you've already crashed into it.
So even though the pilot or the operator is making all the decisions as to where it goes, the internal system within the robot is still carrying out all these safety checks in parallel to make sure that A, the point it's going to is safe, and B, there's no problems with the actual hardware, such as a potentially fatal leak. In such a case, we can make it go up to the surface to make sure it's easy for recovery, or return to a home station where it knows it can be repaired, serviced, or just monitored. These blue dots that you see on the screen is basically what the navigation system considers to be trackable features. It uses a stereo camera, which is just a pair of cameras, monocular cameras, and using those two cameras, it detects features, matches it, knows exactly where that feature lies in relation to the camera, and then matches it onto a database. And over time, it builds this database of map points that allows the robot to consistently track and localize itself within the environment, allowing autonomous navigation. So Santi, we have a challenge for you. So somewhere in the structure, we have a treasure, which is, in this case, a yellow buoy. So if you would like to attempt to try and find this yellow buoy around the structure, and then if you manage to find it, then, well, we don't exactly have a prize, unfortunately, but you can pat yourself on the back knowing that you're a great operator. So you've only really explored one side of the structure. So if you really want to kind of try and go on to the other side, so the blue dots is kind of like a good guidance to kind of figure out what shape the structure is, where it's not being explored, where it's potentially available to find new features. Oh, there we go. Off he goes exploring. So you can cancel the waypoints you send by just giving it a new one as well.
So Claire's asking what the QR codes are for.
So the markers that you see on the structure, we use these to validate our measurements. So we can take measurements of the structure using the camera. And we've used this offshore to take measurements of wind turbines and meteorological masts and other structures that are present out in the sea. But when we're testing within the tank, we want to make sure that everything that we've developed is as accurate as possible. So we have these markers throughout the structure that we know the distance between. So when we create our map of the structure without reading data from the markers and just building a model using only the cameras, we can then compare that to a model made using the markers, knowing where every marker is. And we can use that to work out how accurate our 3D model is. And so far, it's been passing all the tests, and it is very accurate. Dylan asks, what would happen if the water was moving? Would the robot be able to stay in a fixed position? So using the thrusters on the robot combined with the SLAM, the simultaneous localization and mapping, so the position tracking that we get through the stereo cameras and some of the other acoustic sensors that we have on board, we're able to detect where the robot is and how it's moving. And we can use this data to hold it in place and give it more power against the current to make sure that the robot does not get blown away by the current under the water. Now, the robot that we have in the tank today, our Blue Rov, it's quite a small vehicle. It works well inshore and near shore, but for when we're offshore, out at sea, we use our larger vehicle behind Matthew. Matthew, if you want to point. We have a larger Falcon ROV, which is capable of 3 knots. So that allows for you to work in moderate current out at sea.
What's the worst
What's the
underwater
worst
crash
underwater
we
crash?
ever had? Well, we actually had quite a disastrous situation quite recently, where which was very close to this event actually, and kind of made us quite unsure whether we were going to be able to fix it in time. But basically, what happened is that all the computational hardware and the electronics are stored in these sealed bottles on the ROV. Now, you can imagine that water and electronics don't really work well together. And at one point, we had a massive leak that we didn't detect immediately. So we had this exact ROV in the water for about 40 minutes to 45 minutes, not realizing that it was slowly filling up with water.
Started to behave kind of strange.
Yeah, and we weren't quite sure at the time, but at the end, to kind of illustrate with this water bottle, it was about this full of water by the time we finally got it out. That kind of wrecked quite a few systems and was quite a hassle to try and get working again for today, but we're here.
But we're here,
Yeah.
It's working.
But other than that, I suppose there's that one time when we were offshore in Blythe where we basically kind of got the ROV tangled around the wind turbine with the tether. And it was quite a challenge for Josh, who was operating it at the time, to untangle itself in pretty high tide, was it, that you were doing it in?
Mid-tide.
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 Still
So
relatively.
quite high current.
Yes.
Yeah.
Yeah, that was quite a challenge.
Yeah, that was a scary experience. But yeah, we solved the problem.
So Santi is quite close. He is getting close. Oh, you're trying to reach for. Oh, you're pointing at it. He's pointing at it. He's pointing at it. It's right there. Found the yellow buoy, which is today's treasure. Well done, Santi. Very proud of you. Very proud of you for finding it. So, thank you very much. We very much appreciated all the questions and also had fun watching you all play around with the system and then test. So thank you again very much for taking part, and we hope to see you again sometime soon.
Thank you.
Cheers.
Goodbye.
Bye.